carbonyl compound. So write the topic, that is bonding in carbonyl compound. In bonding in carbonyl complex, it is basically homolaptic complex. It is basically only carbonyl are present. Carbonyl is a ligand. Carbonyl present. So one type of ligand, that means it is a homolaptic complex. Homolaptic complex. Please do write these 2 points with me, and then I'm going to show you a lot of examples on this and the bonding in carbon, which is very, very important. So you have seen that NiCO4, CO whole 4, and it has a structure, tetrahedral structure it is. So I'm going to give examples of this. This is NiCO whole 4 and this is your tetrahedral. And then comes your Fe, and this is your CO, then this is your CO. It has coordination number 5, so it is trigonal bipyramidal. Then there is a carbonyl compound that is having 6 coordination number like this. You can see it has 6 coordination number. So 6 coordination number, that means the geometry will be octahedral, right? Geometry depends upon the coordination number, yes or no?
Yes, sir.
Please do write it.
Yes, sir. Done.
Very good. Today we are going to start the last chapter, that is amine, after this topic, okay?
Yes, sir.
Now there are some complexes which have 2 central atoms in this way. This is CO, this is CO, carbonyl, and this is also carbonyl. This is also carbonyl, this is also carbonyl. And it has a formula Mn2CO whole 10. Another having 2 central atoms is this CO, that means C double bond O it is, C double bond O it is, and then comes CO. And it has a formula cobalt CO8. Please do write it and let me know when you are done. Let me know when you are done with this.
Yes, sir. Done.
Very good. Now I'm going to show you the bonding in carbonyl compounds, which is very easy and important too. So this is the bonding in carbonyl orbitals like this. Now see what will happen. First, there are two electrons that will donate to this and it will form sigma bond. Now there will be formation of pi bond, that is pi star, anti-bonding. There are two electrons that is going to form pi bond. So basically this is synergic bonding. Synergic bonding. I'm going to write a point about this, then you will get it. Pi star, that means anti-bonding. So first point we can write about this, the M or C bond. The MC bond is metal carbonyl. Metal carbonyl possesses S and P character, both S and P characters. The next point we can write is MC, sigma bond. Sigma bond is formed by donation of, this is your donation of lone pair of electrons of Cu into vacant orbitals. Vacant orbitals. That means this will donate to metal, central metal atom, and it will form sigma bond. It will form sigma bond. Please do write these 2 points. And the third point we can write the bond between M and C. Pi bond will also be there. You can see there is a pi bond is formed by donation of electron pairs of d orbital, that means metal is donating its d orbitals of metal into vacant anti-bonding, that means pi star orbital. So when central metal donating electron to this, so this will be pi bonding. Please do let me know when you are done with this.
Yes, sir, done.
Wait a minute. Very good. So this is it from coordination compound. Now we are going to start a new chapter, as I told you. Are we okay with you? Is the screen visible, Nafisa?
Yes, sir.
Okay. Let's start this chapter. Amines. So before starting the chapter, we are going to see this is also a functional group, and amines is basically, you can see it is divided into three categories. If it is like this, CH3. Do you know how to calculate the degree of nitrogen or amine? If nitrogen is connected only directly to only one carbon, that means it is primary. That means
First
it is
primary, yeah.
primary. That means it is primary amine. And if this nitrogen is connected with two alkyl group, that means it is secondary amine.
Secondary.
Yes, secondary amine, and this is your primary amine. And if you are going to have the third alkyl group, it can be different or same. That depends upon the molecule. It is tertiary amine. Quaternary amine is also possible. If it is going to donate it and make a bond with it, then quaternary can also form. Is that clear? And this primary, secondary, and tertiary amines react in different manners. So that's why we treat them as different functional group. Are you getting my point?
Yes, sir.
The amine we can write is RNH2. And this comes from basically, this is ammonia, NH3, this. These are all ammonia derivatives. How? You are going to remove one hydrogen and put one R there. So it will be 1 degree amine. If you are going to remove two hydrogen, then it will be like this, 2 degree amine. And if you are going to remove all the hydrogen, then it will be tertiary. Are you getting my point?
Yes, sir.
And the structure is also very easy. And I'm going to show you the structure of tertiary. That is basically, this will have a lone pair as well as this will have a CH3. This will have a CH3. tertiary amine, and you know there will be repulsion between these two. So slightly, its hybridization is sp3, and it should have a shape of tetrahedral, but due to the presence of this lone pair, there will be repulsion between bond pair and lone pair, and its structure will be, shape will be pyramidal, and the angle will be 108 degree. Please do write it.
Yes, sir. Done.
Wait a minute, please. Can I change the slide? Okay. Now see, we are going to do the nomenclature part. You see, this is the nomenclature part I'm going to write. Its IUPAC is basically alkane amine. Its IUPAC is alkane plus amine. So it will be alkane amine. Okay. So I'm going to give you some example and then you will get it. So if you have something like this, CH3, CH2, NH2, you can see there is no branch. So the name will be 1, 2, ethane, 2 carbon in the parent chain, ethane amine. Its name will be ethane amine. This is a primary amine. Okay. And if you have like this CH3, CH2, and this is your NH, and this is your CH3. So you have to take one of the alkyl group as parent chain. So you can see here is 2. So it will be parent and this will be substituent, and you don't need to do numbering. You can write this is a substituent. So what I'm going to write, its name will be N-methyl, and then come to the parent chain, ethane amine. Are you getting my point, Nafisa?
Yes, sir.
Why you didn't join yesterday's class for the self-study
Sir, I had exam. I told you,
exams?
right?
Okay, okay,
In
okay, okay.
tuition
I
class.
forgot. Okay, okay. Now, if you have like this, you need to choose one of them as a parent chain. So this there is 2 carbon, that it is a parent chain, and these are substituents. So I'm going to write both are same. So I'm going to write N comma N. Wait a minute. I'm going to write N comma N dimethyl ethanamine. Dimethyl ethanamine. Please do write it with me. Let me know when you are done with this.
Yes, sir. Done.
Very good. I'm going to give some of the nomenclature you need to do. So if I'm going to give you a structure like this, can you do the nomenclature? One. Let me know if you're able to solve it or not. Okay.
Yes, sir. Sir, the first one is N-pentamine.
And N will come in the
And
secondary or tertiary.
secondary, yeah,
See,
yeah.
this is
It's just pentamine. It's
how
5.
many carbon
Oh
it
no, it's
has?
4. Butamine.
Butanamine. Butanamine.
Butanamine. Yeah.
Okay.
Sir, and diethane propinamine.
Diethyl it is. When you are going to
Diethyl,
write,
yeah,
yeah,
ethyl
N comma
propinamine.
N, diethyl propionamine. Very good. So see, both are what? Primary here. Now you can write 1, 2, 3. So propane 1 comma 3
Propin
diamine.
diamine.
What its name will be? Propane 1 comma 3
Diamine. Why 1 comma?
di. Yeah, it is on the first carbon it is, and in the third carbon it is.
Oh, okay.
That's why
Yes, sir.
we need to write.
Understand.
Now you can see 1, 2, 3, and here you can see prop, and on the second carbon it is double bond, so 2 in, and we can write 1 amine, because on the second carbon
Yes,
it is
sir.
double bond, and on the first carbon it is amine. Okay,
Yes, sir.
now we are going to do this. So this is your benzene, right? And if you are going to connect this, it will be amine. So we can directly write benzene amine. We can write benzene amine. Its common name was basically aniline, but now it is treated as IUPAC name. Okay. Is that clear, Nafisa?
Yes, sir.
Okay, can you do this?
N dimethylbenzamine.
Very
Is
good.
that
Its
correct?
name is quite
Yeah.
very good. N comma N dimethyl benzenum.
Yes.
Are you done with this? Nafisa,
Yes, sir.
preparation of amines. Now see preparation of amines. The first one is reduction of nitro compounds. By reducing nitro compounds, you can easily prepare amines, and it's very easy to prepare. Here you can see the reaction is quite easy. If you have a nitro group connected to a benzene, this will be reduced. That means oxygen will be removed and hydrogen will be added in the presence of H2 and palladium in the presence of ethanol. So what will happen? The hydrogen will be removed. That means reduction will take place, and you can see this will form aniline. There is another ways to prepare the same product, and here it can be NO2. And either we can use tin plus HCl, or either we can use iron plus HCl. And again, we will get aniline. So please do write this. We prefer this way.
Yes, sir. Done.
Done.
Yes, sir.
Now the next is the second preparation is from ammonolysis of alkyl halides. Ammonolysis of alkyl halides. So see, what is this ammonolysis of alkyl halide? It is basically you are going to react ammonia with alkyl halide again and again. This alkyl halide will be in excess. Will be in excess. As you can see, if you have ammonia, that means this is the ammonia, and if you have an alkyl halide, this is your alkyl halide. Now you know that this X, that is halogen, is quite more electronegative than our alkyl group. So it will take electron from alkyl group, and this will be acting as nucleophile because it has a lone pair electron rich species. So it will attack on this. So what will happen here? You can see Nitrogen donated electron to carbon. Sorry, R. So it will have positive sign like this. Nitrogen makes only 3 bonds. The fourth bond will be coordinate bond. And as you can see, this is your X. So it will be written in the form of this. Are you getting my point? Nafisa, what
Yes.
happens
Yes.
here? X will take electron from alkyl group, so it will be NX negative, and R will be positive. So R will be positive. R positive will be attacked by this ammonia NH3, and it will attack this. So nitrogen will
Yes,
donate
sir.
electron to R, and it will make a bond with this. So it will be RNH3 positive, and this will be like this. So bond between these two is ionic. Bond between this NH3 positive and X minus is ionic, and R and between all bond after this bond, all bond are covalent in nature. So there can be question like the bond between X negative and NH3 positive. So it is ionic bond. It is ionic bond. Okay. And
Yes,
this is
sir.
your covalent bond. Can you change the slide? Please do write it. Then we are going to do a monolysis. Are you done with this?
Yes, sir. Done.
Now see, RNH2. This is your primary or 1-degree amine. If you are going to react this with RH, so what will happen here? It's very important to note, and this reaction is quite important. So see what will happen. You just need to do one thing. Just replace one of the hydrogen with R. So what you will get? You will get R2NH, because you are going to replace. That means basically you are removing, eliminating one hydrogen and adding R. So it will be R2NH, and this X and H will combine to form a byproduct, that is HX. Are you getting my point? Yes or no?
Yes, sir.
Again, you are going to do a reaction with RX. Again, this X, this R, which will take electron from R. This X will take electron from R, and this hydrogen will be replaced by this. So it will be R3N, and again this X and hydrogen will form byproduct. Now, again you are going to do reaction with this. So what will happen here? It will take electron in the form of X minus. It will be X minus. Now this nitrogen has a lone pair which will attack on this R. So now it will be R4N positive. Again this product forms this type of product. The bond between this and this is ion, and this is basically covalent. Okay.
Yes, sir.
So you can see in the first place it is 1 degree, then 2 degree, then 3 degree. It is not effective, and it is 4 degree, which is quaternary. It is the method is not that much effective. Basically, it decreases if you want a very good amount of 3 degree amine, that is not effective. Okay, please do write it. Let me know when you are done with
Yes, sir. Done.
this. Very good. Now see, if you're going to react this, I'm gonna write the reaction, which is very, yes, if you have this RNS3 positive that we had prepared, and if you're going to react this with NaOH, which is a base, then you will be getting a primary amine, RNH2, along with the byproduct H2O and NaX, which will have negative and this will have positives. So you can write a point which is basically homolysis has disadvantages of fielding a mixture of primary, secondary, tertiary, and quaternary, quaternary ammonium salt. Wait a minute. This is your amines and quaternary ammonium salt. The last one is quaternary ammonium salt. Primary is obtained as major product. Primary is obtained as major product.
Yes, sir. Done.
Very good. Now we are moving to the next preparation, the third preparation, and that is from nitriles. So we do reduction here also, reduction of nitriles. So how we are going to prepare and how we are going to do reduction of nitriles. You can see the reaction is quite easy, RC triple bond N. And if you are going to react this with H2 in the presence of nickel, or either you can use sodium amalgam, NaHG, in the presence of ethanol, then you will be directly getting RCH2 NH2. How the reaction take place? So it's very easy to understand. You can see this is your RC triple bond N. Now what you need to do? Just break one of the bond and you will be adding hydrogen here and hydrogen there. Again, you are going to break one of the bond, adding hydrogen here and hydrogen here. Now what it becomes? It becomes CH2 and it becomes NH2. Yes or no? So this is your primary amine.
Yes,
So
sir.
by reduction of nitriles in the presence of H2 and nickel or sodium amalgam in the presence of Fe2H5OH, you will be getting amine. So this is the third method. We have three more methods. Please do write it and then let me know.
Yes.
Very good. Now the fourth is basically the fourth is reduction of amides. A reduction of amides. If you are going to do a reduction of amides, what will happen? So you can see, you can write a point. The amides on reduction with aluminum hydride yield amines, yield or produce amines. So you can see if you have amide, now what you need to do, and if you're going to do lithium aluminum hydride followed by hydrolysis, what will happen? See, it's very easy. One of the bond will break, one of the bond will break, hydrogen will be added here, hydrogen will be added here, one of the bond will break. So you can see this part is basically H2O, and this becomes RCH2 and then NH2. This is what H2 will be, not H2. H2 is in the solution, so it will be eliminated. Got it?
Yes, sir.
Please do write it.
Yes, sir. Done.
Okay. Now see, we have the fifth one. Fifth preparation, that is Gabriel Thalamide synthesis. Thalamide, this compound you have seen in aldehydes, ketones, and carboxylic acid. So see what will happen. We are going to take thalamide, and thalamide is this. This is your thalamide. And if you are going to react this with KOH, so this hydrogen's place will be replaced by K. So what we will get? We will get this. All will be same, only this hydrogen will be replaced by K. And K is metal, so it is electropositive, and this is electron negative. Now you are again going to react this with RH. First, you are going to react it with KOH base, and now you are going to react it with alkyl halide. So now this will be replaced by this, because this will have negative, this will have positive sign. So this will go with this, and KX will eliminate it. So you can see you will be getting this part. You will be getting this C double bond O, and then C double bond O, and then N, and then R. And this is basically N alkyl thalamide. N alkyl thalamide. Now, if you are going to react this part with NaOH aqueous, then you will be getting a primary amine. So you can see the byproduct that will look quite big. This is your byproduct. This is what your byproduct looks like. This is your byproduct. And the main product I'm going to write here, that is primary amine. And this thalamide Gabriel synthesis is used to prepare primary amine. Is used to prepare primary amine. Is that clear? Nafisa, is that clear? Please do respond. Nafisa, are you there?
Yes, sir.
Please do let me know when you are done with this.
Yes, sir.
Done?
Yes, sir.
Very good. So this method is used to prepare primary amine. After this, we have the last preparation.
Yes, sir.
That
Can you
is,
hear me?
yeah, I can. Am I audible to you? Are you there? Nafisa?
Sir, can you hear me?
Nafisa, am I audible?
Yes,
Yes,
sir.
yes, I can hear you. Okay. So the last preparation is basically what is Hoffman bromamide degradation reaction. And degradation is because the number of carbon that you will be using in a reactant and the number of carbon that will produce in product will always be lesser in one than one. Are you getting my point? If you have
Yes,
four
sir.
carbon in reactant, you will be getting three carbon in the main product. Okay,
Yes, sir.
that's why its name is degradation. So I'm going to write the reaction first. So this is your amide, bromamide. That means this amide is going to react with bromine in the presence of this, that is NaOH. So you will be getting this part first, C. This will combine with this and this CO will be eliminated. So you will be seeing that this what you got, and one carbon that is present in reactant will come with this and form Na2CO3 along with this part. Okay. So degradation is that degradation is because the number of carbon that you have used in the reactant and the number of carbon main product, the number of carbon in the main product will always be lesser than one in this. Okay.
Yes, sir.
So I'm going to write a point in this degradation reaction. Migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. The amine so formed contain one carbon less than that present in amide. If you have any doubt in this, please do let me know.
Sir, can you scroll up?
Yeah, yeah. Is it okay?
Yes, sir, before the Hofmann bromide degradation reaction.
Do I need to scroll up more? Please do let me know. Nafisa, are you there? Nafisa,
Yes, sir, can you hear me now?
yes. Have you written it? The Hoffman
No,
bromamide
sir.
and
Yeah,
Gabriel,
but this, yeah, Gabriel, not yet.
you haven't written it, right?
Yes, sir.
Okay, please do write. Nafisa, are you done with this?
Yes, sir.
Please do write also. Are you done with this?
Yes, sir.
Very good. Now we are going to do. Can I change the slide?
Yes, sir. Okay.
Now, here our preparation completed. Now we are going to do the chemical reaction. Chemical reactions. To see, first of all, when we are going to talk about the chemical reaction, first we are going to take acylation. That means we are going to react amine with acyl halide. So you can see how you are going to react. It's very easy. There is a primary amine. This you can easily understand that this is your primary amine. And if you are having acyl halide, which is this acyl halide, now you also know that oxygen is more electronegative element, so it will take carbon's electron, and carbon will have deficiency of electron. Carbon will have deficiency of electron, so it will attack on carbon to satisfy it. And this reaction will be taking place in the presence of base. So what I'm going to do, I'm going to do this, write this first. CCl O will have negative sign because it took electrons from carbon, and CH3 as it is. Now this nitrogen attacked on carbon, so nitrogen and two hydrogen with nitrogen were present, and nitrogen, this is like this. And since nitrogen donated one of its electron to the carbon, so it will have positive charge. Yes or no? Please do let me know.
Yes, sir.
Now Nitrogen is the third most electronegative element, so positive charge is unstable, so it will take electron from this hydrogen, and this chlorine will be taking electron. This chlorine will be taking electron from carbon, and this oxygen will give an electron from to this. So what will happen here? See, this C, and then there is double bond O, because the electron that oxygen has taken, it gives again to the carbon and it makes double bond, and this CH3 I'm going to write it on the right hand side, and then you can see NH. Hydrogen took electron from nitrogen took electron from hydrogen, so it neutralizes itself, and this is what you have got, amide. Is that clear? And its name is an ethyl ethanamide.
Yes, sir.
Please do write it. Are you done with this?
Yes, sir. Done.
Now see, the chlorine from here and hydrogen combine to form HCl. You know what you need to do? Just remove this chlorine and one of the hydrogen from nitrogen and add this carbon. This and this will combine and it will be eliminated. Is that clear?
Yes, sir.
So
Yes, sir. Okay.
if I'm going to give you a question, this is your C2H5 and this is your hydrogen. This is your CH3 C double bond O. Just let me know the product, final product, this product. I'm Are you able to solve it?
Sir, it's the same like before, but below instead of H, it would be
See what will happen. This will together eliminated and this will be here. So what it will be? Nitrogen make bond with this carbon and this nitrogen has two group. This is what I told you. Just remove this chlorine and hydrogen from nitrogen and combine nitrogen with the carbon from where chlorine is removed. Got it?
Yes, sir.
And its name is N, N diethyl ethanamide.
Yes, sir. Okay.
Did you do correctly or have you wronged it? You did some mistake.
No, sir, I did it like that. But then
Okay. Yeah.
it's like on the opposite side. So it's N. It's the N in the left on the left side.
Okay. Did you do like
Yeah,
this?
like that. Yeah.
Can you match it? Or did you do this or something else?
Yeah, I did that.
So both are same.
Yeah, okay. So I'm correct.
Both are same. Let me know when I change the slide. Can I change the slide?
Yes, sir.
Okay. Thank you. Now see, when you are going to react with acid anhydride, this is your acid anhydride. So what will happen? Again the same. You just need to break one of the bond. You know this will have positive, this will have negative, and this will have positive, this will have negative. So this negative will directly come here. So I'm going to write this part first. So it will be, wait a minute. I just did it wrong. This negative part will come to this positive. So I'm going to write this part first. Are you getting my point?
Yes, sir.
I did some mistake. There is negative and negative. I just made them equal, negative to negative, but it will go in negative to positive. So CH3, C double bond O, then N and hydrogen. And then this is your C2H5. And you can see this positive will go to this. So it will make carboxylic acid. Please hold on a minute. I'm back. Let me know. I'm back now when you're done with this. Nafisa, are you done with this?
Yes, sir, I'm done.
Okay. Now the next. is basically carbolamine reaction. And basically, this is very important reaction, which is also known as isocyanide test. So write a point with me. Aliphatic and aromatic primary amines on heating with chloroform. On heating with chloroform and ethanolic, that means alcoholic, potassium hydroxide form isocyanides, or we also say carbolamines, which are foul smelling. Secondary and tertiary. No means do not show this reaction. This reaction is known as carbolamine reaction or isocyanide test, and is used as test for primary amines. So basically, the reaction is quite easy. This is test for primary amines. If you have amines and you are going to react this with, you can see this is your primary amines. And if you are going to react this with chloroform, and this is your ethanolic potassium hydroxide, and heat it, then it will form isocyanide PKCl along with H2O. If you have any other amines like secondary and tertiary, the reaction will not occur. The reaction will not occur. So it is also treated as, please do write. Let me know when you are done with this. Okay.
Yes, sir. Okay.
Then Nafisa,
Yes, sir, done.
okay, Nafisa, will you be available on Friday at same time, 6:30? Yes or no?
Kuwait time, 6:30.
6:30, this Indian timing 6:30.
Yeah, I will be.
Like the time today we had. Okay.
Yeah, okay.
That means at your place it is 4 p.m., right?
Yes, sir.
So on Friday there will be an extra class and we will